I've bought this and it doesn't work. Brilliant, hey? Hey, you loopers, welcome back. Hope you're going to enjoy this video as much as I do. I'm going to try and fix this today. Might work, might not, who knows. But let's give it a go anyway. I'm just going to move this out of the way because it's just the empty case. So, background to this. I bid on it on eBay. And I only went and won. Can you believe it? So, this thing then arrives in the post, and lo and behold, it doesn't work. Absolutely fantastic. But it's just the sort of thing that I like to buy. So, here we go. Now, where I've got to so far, I have done a small amount of research. I've taken the board out of the case and I have run a few tests on it. And I'll probably show you where I'm up to. So bear with me, and we'll see how we go on today. Let's switch over. No idea how this is going to go today. We could end up with some technical difficulties. Or anything could happen when you're live. If you want to say hello, smash a comment, and I'll keep an eye on the comments as we're progressing through, and hopefully we can try and be a bit interactive seeing as we're live. So onto the desk view. I swap over so I can see that as well. This is the main board. That's inside the Atari. It's an Atari 65XE. So it was one of the basic ones. It was one of the basic ones. And they have got quite a lot of custom chips. Let's switch over onto... Yeah, there we go. Sort of got... There's me. It has got quite a few custom chips, so they give each chip a code name as well. So this is the processor, which they refer to as Sally. This one here is Freddy, which is the memory controller. This is the RAM down here, and this motherboard was fairly generic, so I think it was fitted to the 130XE and the 65XE, and the only differences between the two, on the 130XE, this part here, I think it was, had a chip fitted as well as this one, and all of this RAM bank would have been populated, so you'd have had two full banks of RAM there. They have, interestingly, already done some kind of modification. So this here is very interesting as well. And it would have been nice to know how many boards that had to be done to. Right, so where I've got to so far, I had downloaded some resources and I found this guide here. This guide here. Which was some kind of technical repair manual, which came in fairly handy. It is, as I say, you can see it's meant for the 130XE, but the 130XE and the 65XE are fairly similar, just that the 65XE is cut down a little bit. So back onto the manual. This manual breaks down the schematic. We've got the schematics in there, which is great. But also, interestingly, it places on there on the screen, you can see some oscilloscope waveforms and particular points and the signal that you would expect to see. Back onto here, yeah, right. That's what you'd expect to see, which is very handy indeed if you're looking through trying to repair this. So further down, as you keep scrolling and scrolling and scrolling, got all the chip identifiers on there, find out which all the parts are. There's a couple of different types of motherboard, so if you're fixing one of these, have a look, and basically you're looking at this code here. Make sure I'm showing you the right thing there. Yeah, so that code there is what you're going to be looking up to find out which motherboard you've got fitted in your particular Atari. Okay. Where were we? Yeah, so back over to me and the screen. Right. So as you get through this, there's this troubleshooting guide here, and it explains the self-test operation, the process of operation. I've started looking through this section here, clock and dividers, and the clock signals that we would expect to see are in place. So that was a good start, really. It shows that the whole board isn't dead. There is some kind of activity in there. When you plug it into the monitor, you don't get any output whatsoever. So it's definitely inoperative. And I've then progressed through some of these checks we can't do because I don't get far enough. But I'll show you where I've got to. Bear with me while I find this. Make sure we've got that yet. We haven't got much going on the stream. If you want to say hello, and I'll keep an eye on that every now and again, but I have got to switch through. So back to this. The board powers up. We have got the clock signals. As we follow through this troubleshooting guide, the reset line goes high pretty much straight away after power. And there was a section in here which specifically mentioned something odd, which I saw when I was looking. The data lines on the processor, they start out really good, and then shortly after they stop. And the problem with that is this manual, lo and behold, we're live, so I'm not going to be able to find it, no doubt. That's a keyboard, group of keys. Essentially, it pointed out and it said it could be the processor, it could be the memory controller, or quite a few different things actually. But one of the interesting things that I found, I'll try and demonstrate this to you, was that the RAM, if you look here, there is a bit of a clue. Here, go back onto the board. What I did notice on the internet, it does say about the RAM in these particular computers, and in fact quite a few all around this era. You know, this is dating back. I think it's about 1985. It did say the RAM are known for going bad. Now, one of the signs that the RAM's gone bad is it gets hot. So, what you do, you check each RAM chip along here, and you use the old finger test to see if it's hot. If your finger flies off and you go, then yeah, that one's definitely faulty. But for this particular board, it didn't seem to do that. So what we'll do, we'll put my static strap on. We'll power this up, and we'll start to look at these signals. What I noticed was, if you look here, these chips have been soldered on, and this one here is fitted in this header. So definitely at some point this board has certainly had a repair, and this last one here isn't fitted into a header. Now the problem we've got, we don't actually know which chips are faulty, if they are faulty. But with this powered on, I'm not really feeling any heat in there. So initially, my thoughts were that it's only this one chip that's gone bad and the rest of them are okay. But let me try and get some of these test clips on here, and we'll get some signals up on the screen, and I'll try and show you what I thought was a little bit unusual. So I've got the data sheet here for the RAM chip, and the output of the RAM chip is pin 14. So I've already got one test clip on here onto pin 14. And what I'm going to do for comparison, I'm going to stick another RAM chip on to that one. What I'm going to do is I'm going to stick another clip on here. So I've now got this logic analyzer, which is here, Salier, connected up, and we've got this chip and this chip. We're actually going to be able to see what waveforms are going on there. So I'm going to switch over to the logic analyzer. And oh right, here we go. Yeah, we're just checking the comments there, see if I'm delayed on this. Alexandru, big up Alexandru. I know you're a follower on Instagram, so yeah, welcome. I hope you enjoy it. So back over to the logic analyzer, which is lo and behold complaining. Already seen as we're live. That there's nothing connected. Over to the screen. Amazing. What I'll try doing is I'll try unplugging that and plugging that one back in again. Let's see if we get any connections going on. Connection completed. Right, yeah, okay. We've finally connected back again. The screen and A6400, so that's the screen and that's me. So I'm going to have a look on channel 0 and channel 1. I'm only going to capture 3 seconds of data, and when I click start, switch on, we grab some data. Now, hopefully you can see this. I've only just started using this software, so fingers crossed going to show what I want it to show. So, if we look at these waveforms here, what we can see is that it starts up, I think it's about 2 seconds. So 2 odd seconds, 2.5 seconds. Obviously, it depends on the exact time as to when I've actually switched it on. 2 seconds later, these channel names, don't worry about them. Reset them. On channel 1, which is, this is channel 1 here. And this one here is channel 0. So channel 0 is the new RAM chip, or the replacement RAM chip, which of course could be faulty as well. Yeah, good luck. Yeah, I think back on that one. Yeah, good luck. Thank you. I might need it. You know, anything can happen when you're live. So fingers crossed, we make some progress. Fingers crossed. Back onto the desk. And back onto screen, actually. Screen and me. Right. So, what I noticed is that this event here looks particularly interesting. Now, when you're trying to fix this thing, anything that you can leverage or get a clue is a big help. And certainly here on channel 0, which is the RAM chip that's been replaced, there is a continuing waveform, and this looks like some kind of data access or refresh. These RAM chips, you need to refresh them to keep the RAM values stored. But when you look on this channel 1, which is the, what I would suspect is the original RAM chip, which is obviously 35-ish years old, possibly, there's certainly a very different waveform going on here. And this carries on all the way through, but it is also erratic. So in my mind, the first thing I'm thinking about is, could something be happening regarding the RAM? So that's going to be my first port of call. And quick refreshment break. So I'm thinking, well, looking at this, it doesn't add up that this has been refitted in a socket, and the general practice is whenever you're working on an old board like this, particularly these RAM chips, would be as you take them out, you're going to refit them with a socket. So that one's definitely been done, and that one's got the signal that we can see here is still operational, maybe, but certainly that's an area for us to certainly have a look at it and investigate, and that carries on until you switch it off, basically. What I'm initially thinking is that these RAM chips are bad, or one or more of them. And in fact, actually, the only one with what I suspect is a good waveform is that one that's been retrofitted. So I think I'm going to take some action over that. And what I've purchased is, focus on that, not on me. I purchased another set of RAM chips. Now, these RAM chips, you're going to struggle to buy brand new. So I think they're new old stock or machine pulls. or something like that. So the plan of attack is we are going to have a look through. We're going to desolder the RAM, and we're going to stick some sockets. We're going to pop some sockets on and see how we progress from there, really. I'm also going to open up these holes here and fit sockets on these, and we'll see how we go. I mean, it is live, so it's this part of it's probably not going to be that that thrilling and quite a long progress as well. But yeah, hang out on a Sunday and drop us a comment, and we'll see how we progress. So I think next step then, we'll get the soldering iron on. We've got our flux handy, and we'll see what can go wrong next. Move this keyboard. Get that out of the way. And I think what we'll do, we'll power off, definitely. We'll remove our logic analyzer. Like so. Pop that out of the way now. Like that. I'm going to prep up and get ready to be solderer. I did get a new desoldering tool, which is not that one, that one. Focus on that. We'll put this through its paces and see how it goes. The desk. Just check the comments while the soldering iron's heating up. No new comments. Hopefully, fingers crossed, you can all hear me okay. And I don't know, what are we in? However many minutes in we are, 22 odd minutes already. Could be a long Sunday afternoon. So, if you are enjoying yourself, feel free to hit the like button for me. And what we'll do, we'll have a look at this board. We'll turn it over. We'll see if we can get some soldering going. Right, I'm going to move this over onto here. I can close my logic analyzer. Right. Okay. Unplug this. While we're soldering, I'm just powering it actually. I've got this USB battery bank, and I've got this lead that I purchased from eBay, which allows us to power this just from a USB connector like so. I'll keep that there ready. I'm going to go and put this battery bank on charge. So yeah, this is this part of it's going to be more like hanging out, hanging out and doing some soldering on a Sunday. So what I'm probably going to do, I might leave that one in actually. We'll leave that one in. So let's go. For nearest one first. See how we get on with that one. Okay. Anybody's got any comments to make at any time, feel free. Hopefully I should be able to respond a bit quicker to any comments now, because I've got both windows open on the screen at the same time. Pop a bit of flux on here. Some flux on your finger. Some of these as well. And fluxed up. Of course, you know what's going to happen now. I'll be, what flux am I using? 2 seconds. I'm just going to remove that flux from my finger and I'll show you. And we're back. Hopefully. Right then. What was I using? So there we go. That's what I've been using. It was an eBay purchase. No, Amazon purchase actually, that one. Amazon purchase and a quick delivery as well. Hopefully that's answered your question. So what we'll do, see if we can get some of these sorted. Hopefully everything's still coming through okay. Right then. Try and get this so you can see it. And we've got this desolderer as well. Right then. So this desoldering tool is supposed to be the best thing money can buy. You've yet to see that. The thing about it is it's got this extra silicone nozzle, which is supposed to be better for sealing around soldering iron and getting rid of the solder, as we can see. So let's try one more. Yeah, not doing too bad a job. So I think what we'll try now, we'll go down, we'll try and get this particular chip out here. Oh, that's not too bad. Yeah, I'm quite happy with that. Anybody else has used one of these, let us know in the comments. Knew I had this job at hand, so I thought, well, we'll give it a go. Yeah, that's fairly good. The idea is, hopefully, we're after a fairly clean extraction of these chips from this board. And if we can get them out without overheating them too much, then my plan is to build a little RAM chip tester. So that'll be a project coming soon. A YouTube channel that you know well. It'll probably be either Arduino based, or I might even have a go on the Pipe Eco. I don't know which would be more popular actually. Do we think the Pipe Eco is more popular at this moment in time? Seems to have a bit of a buzzword. I usually struggle with normal flux wick. Seems like a device like this could be a helpful tool. Yeah, actually, so far I'm fairly impressed with this, because normally I haven't got any to hand, but the normal desoldering tool that I use, it's just got the, try and get that in focus, it's just got the plastic nozzle here. Normally what I tend to find happens is that after a short period of time the plastic nozzle recedes back and you end up seeing the metal plunger at the end, and then you don't really get a good seal, and it normally ends up doing a rubbish job. Now this one so far seems to be working really well, to be fair. Obviously I don't know what the other side of the board's like, but we'll carry on and work our way through. Now if you're using the copper braid along with some flux paste on that braid, then yeah, sometimes that can work. But the problem is with this old board, better angle, with this old board, it's always a concern because of the solder, how long it's been there, and you might find it doesn't actually flow that easy. So I decided this time to go with this desoldering tool, and actually, yeah, I do like it. Now, this silicon end will at some point need replacing, and you do get a tube, a replacement tube that you just cut down to length and fit that on. It'll be interesting to see how this progresses as time goes on. Obviously, once the tool itself gets contaminated with solder particles. And I think 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I've gone overboard. I've started to desolder the capacitor. Yeah, we'll leave that one. Put a bit of solder back on with that one. So let's have a look and see how successful that's been over on the other side. That's not done too bad a job. There's some excess solder on that second pin in. We've not done too bad a job. I don't know how close we are to getting a lift there. Yeah, it's still fairly well in. It is still fairly well in. Yeah, so Ideally, I did want these pins, these chips intact. I did want them intact, ideally. The reason being, I wanted to test them after the event. So try another trick. That one was there. Right. Yeah, I think I'm going to find it quite hard to get these out intact. Won't I? Try and go across the top, maybe. The second pin in there has definitely got quite a lot on. Which will be this side here. Try and get some more in on that. Yeah, it'd be quite a shame just to go through and cut all the pins on them. I don't think I'd want to do that, to be perfectly honest. Get some heating on there, couldn't we? And try and lift it maybe. This is where I need one of the Dill soldering extraction tools. Heat all the pins up at the same time. Yeah, tell you what. See what else we can break. Do want these chips out. I think it's because they're seated nice on the board. Trying now is a different tactic. See if we can persuade this chip to pop out. Try and free it. So all I'm doing is heating the pin, giving it a wiggle. Some of them were successful, I think. Ooh. Get this one. Yeah, so we've got 1, 2. That one probably. That's a no. See how fairing now. What I might do, get that on there. What I might do, see how we get on. See how much solder's holding them in. Not a lot there at all. Not a lot at all. So 1, 2, 3, 4 was definitely a bit in there. And that one, I think. So try this. Yeah, that's a lot more freer. And 1, 2, 3, 4. So it's panning out. 1, 2, 3, 4. Okay, have a look at that. See how we get on. Hopefully that's still on screen. Yeah, we've still got a bite on there. I think it's most of these pins actually. It is most of them. Can you believe it? Very good, that. Try a cheeky push from this side. Yeah, ideally, I do want the little soldering tool, don't I? That'd be ideal. What should we do, people? Should we just cut the legs off? For speed? Is everybody really gonna sit here? watch while I painstakingly bearing in mind I've got 7 of these to do. 7. You haven't got the right tools for the job in hand. Still thinking what to do. Good old live streams. How's everyone's day going? Let's make some small talk. Right then. Get my soldering iron back in operation again. See if we can apply a bit of heat down the side and see if we can get a lift on this chip. What do we think? I think it's a no. What I think it is, the chip is really well pushed down onto the board. So I think where the pins widen out as it gets towards the body, they're making contact with the circuit board on the top. And the holes are fairly well fit in. Didn't really want to kill all of these chips. Yeah, there's quite a bit of solder holding them in situ. A day going good. Doing some trigonometry practice. I'm watching you. Yeah, thanks for sticking in there. watching the stream. How are you getting on with the trigonometry? Have you got some examples to do, or is it just your own tests and revision that you're doing? We did get one pin moving there. Ah, look at that. Look at that. We've got one side lifted. There's one pin. One pin, can you believe it? So, with one pin out. Fantastic. We might even get one of them saved. It's some exercises from the book practicing for the exams. Yeah, good luck. Good luck. I think that's in a week or 2, isn't it? You've got those exams. In fact, interestingly, trigonometry, the foundation for that is really useful in lots of different sciences. Right, let's try and get this other side out. In fact, what I might do, I might even just replace one RAM chip. Back onto the screen, yeah. Yeah, just to say, yeah, good luck for those exams. Hope you do really well. Whatever you believe in and what you are seeking is always seeking you. So believe in yourself, try hard, and put some study in. I think you'll do absolutely fine. Right. So try and extract this chip again. we'll try and do is exactly the same. Exactly the same. Wiggle that. This one there, that feels a bit of resistance on that. Yeah, that's it. That's got quite a lot going on. Yeah, it's an interesting task, that's for sure. I'm guessing when Descane 6400, yeah, just to touch on that comment, your struggles is exactly why chip sockets exist. I can tell. Yeah, 100%. Yeah, this was already socketed up. That would have made my day. But I think when these devices were being made, eight chip sockets, it all adds up to the cost. Although they're buying in bulk, and you're probably looking at a few pence in terms of costs and things like that over, I don't know how many units these sold. I'm guessing they've probably sold in the millions maybe. So it's definitely a cost reason why they haven't fitted sockets in the first place. And plus, I think the other thing is as well, it's about how manufacturers thought whose problem it would be to fix them and repair them. You know, as long as they lasted past a certain date, then the chances are they'd sell a new one, or times would move on really quickly and people would be buying, which they did. You know, the 16-bit, 32-bit times did soon move on, which doesn't make it any easier now when I'm faced with this task. Now, ordinarily, you know, if you was doing this as a costed repair for somebody, you certainly wouldn't mess about like I'm doing now. You go straight down the chip legs with your cutters, and you just cut all the pins off the chip. It's only because I want to actually try and save the chips, just so I can test them really. The only trouble is the amount of heat damage is getting a bit of a concern. But what can you do? What can you do? So, see how close we are now. Because when you've got one side out, you've normally got a bit of an advantage, because what you can do normally is give them a wiggle and it'll just break off any remaining wisps of solder. And then fingers crossed, like hey presto, we've extracted one chip. So Descane 6400 We have extracted one. So smash that like button. Smash that like button because that's good news. Back onto the desk. What I think we'll do, I think we'll place that to one side. I'm going to clean this up. And I think I'm going to stick a socket on it. Put one of the new chips in. And we'll logic analyze of it again. And see if there's a difference on the waveform. Now, if the waveform on a new swapped in chip acts like that one that's already socketed, that would give me confidence that we're heading in the right direction. The problem we've got is it might not be. I think that manual, lo and behold, I couldn't find the exact spot, but it listed 4 chips. The 4 chips that I haven't got, it's the processor, the memory manager, a couple of others as well. So we don't really want to. It's more about building confidence in the repair that we're currently progressing towards. Okay. So we'll try and clean this up. Have a look on there and see how we're diddling. Yeah, I've got a few bits of solder and contamination. You've just joined us and you're having a good time watching me suffer desoldering this chip, then please feel free to smash that like button. Just clean up any crud. We'll stick a socket in. I did buy a pack of sockets, some dual sockets. Those 2 have come from Amazon. And I think that was the one I desoldered, so we'll just get a bit more solder on there. Came from Amazon, but the packaging was really bad. They were wrapped in bubble wrap in a plastic bag. And I think over 50% of the sockets had bent pins, and there was a couple of them which were pretty much unusable. This is the joy that we get. I'd have much preferred to have got them in tubes. But hey ho, what can you do? The stuff delivered quickly. Yeah, you can just see, whether you can see on this camera there, that hole there, that was obviously where one of the pins was still being held in place by some solder. To be fair, it's not something that you tend to do now unless you specifically need the chip is to try and save it. Most of the time you'd out it and bin it. But lo and behold, I wanted to try and save it. For some strange reason. Only because it will come in handy to actually test. I mean, obviously it might be that it's the processor that's kaput. And in which case I've just wasted my time. But these are the way things go, and these are your experiences. You can only try your best at the time. So what we'll do, these are the sockets. As you can see, they were packaged really, really well. I noticed none of the... Get my screen and me back on. Desk and me. Desk and me, yeah. I notice... comment there. I noticed none of the components are actually easily replaceable. The thing's not upgradable at all back then. Yeah, it's correct. You know, none of these are in sockets. If you look on YouTube now and you see repairs that other people have done, you'll see that most of these are all socketed. Even the bigger chips, these 40-pin chips. And interestingly, in the event that they do end up having to be replaced, I have already got some 40-pin sockets ready. Now, they came in packed in tubes, so hopefully they're in good condition. My experience is this board was pretty standard with all these fitted like this, and if you had to replace any, you would have gone through the step that I've done now, except you wouldn't have wasted your time doing what I've done. You'd have done a straight swap out, a pair of cutters, and you'd have just gone straight down the side, cut, all the way down the side. The same on this side. And then you can use a soldering iron then to remove these pin by pin, clean the holes, and stick another one back in. I'm not so sure whether one of the factors would have been costs. And I have got a data sheet here that actually listed, I think I found it, if you just bear with me. There you go. So, there we go. Go on to the single screen. Whether you can see that. There we go. So the motherboard itself was 167.43. I'd probably say this is dollars. And as you're looking down, there we go. So there's a custom chip. I think that's going to be dollars. $5.10. The owner's manual. Even down to the capacitors, 13 pence, 88 pence, 88 cents. I think they're in dollars. So my feeling would have been they've not fitted them for cost purposes. Would be my instinct. And I think, did they think about having to repair it? Or maybe any under warranty would have got sent back to the factory and just had a whole main board swap. I think by the time it gets to people replacing the individual chips, it's probably going to end up as a third party. And I'm guessing, I'd probably even carry on and saying that these would have most likely been replaced by TV repair shops. I think would have been, where they'd have likely have gone to and been repaired purely because the skills would have already been taking place in TV repair shops. So my plan here is, I'm going to try and clean this up a little bit more. I'm going to fit this socket, and then when we fitted the socket, I'm going to stick one of these back in. I made a bit of a mistake by fluxing all of the chips, So obviously now I've got all of this goo going everywhere, so we're going to need to have a bit of a clean up. But I'm going to get one chip back in, and I'm going to get the logic analyzer on it and see if the waveform is any different. So I just need to get something to clear this up. So 10 seconds and short break, 10 seconds. I'll be back. We're back. We're back. Right. Give this board a bit of a clean. Give that board a clean. Clean up on that. And over on the other side. With this old board, obviously the amount of heat that I've just put in as well, I do want to try and have things cleaned up nicely. So clean that up. We'll pop some more of that flux on. Then we'll get that socket soldered back in. Right then, next stage. Okay, pop that to one side. Definitely need to make sure I clean all that up. Last thing we want is that shorting anything else out on the circuit board. How's the weather for everyone today? Fairly hot here today, which is fairly unusual for us. Right then, I think we're about ready to get back into this. We'll do. This flux back on. Okay, so stick one of these sockets in. Make sure we orientate it the right way. Been stormy around these places. Sky's only just cleared up. Yeah, it's. I thought there was going to be. A storm for us at some point, but we seem to have escaped it. Okay, so 16-pin socket. we're going to pop that in, get it soldered up, stick one of these other chips in, have a look at the signals. We have got a little notch on this side there, you can see that. So we're going to orientate that so it's the same way and that the chip's going to be fitted correctly in due course. Pop that in there. Ooh, looks like we've got a blocked hole. There we go. Right, that's in situ. What I'm going to do, make sure all the pins are through, which they are. I'm going to solder a pin up. Like so. And then make sure it's flat to the board, which it's not at the moment. So what we'll do, one on the other side as well. And then I'm going to hold the chip on this side and then just heat those two solder joints up, and then that will then hold the chip in place, the chip socket. Make sure that chip socket's nice and flush. Which it is. On camera. Like so. Now, just going to solder up all of the rest of the pins. The idea as well, if you socket these, if you end up with 2 or 3 computers, you can then swap the chips. If you've got a known working board, you can swap the chips about to an unknown one. And you can soon fault find really quickly. That's your other reason for sticking a socket in, and it would have been lovely for all of these to have been socketed. We'd have been over and done with this a lot sooner. Right, that's those soldered. Inspection them. Happy with one of these. Bit more solder on. These sockets were really cheap. Okay. Next thing I'm going to do is just check these for shorts. Run through there. Make sure I'm happy. Last thing we want is a short between one of the pins. Otherwise you end up chasing your own work, which is never good. Never good at all. Okay, happy with that. Another quick clean up. Another clean up. Okay. That's my socket back in. So, next step. What we'll do, we'll switch the soldering iron off for a bit. Wait for that to dry. And then we'll power this board back up. And we'll see if the waveforms are any different. Who knows? Who knows? Just give that a few more seconds. Solder out of the way. Right then. So we want that in situ. That. It's back on camera. This plug back into the power socket. Like that. Battery. Okie doke. Goes into there. That's off. This again. I'm pretty sure that side was 0. Let's just test that out. Yeah, so this is the 0 side and that's the 5-volt side. That's connected correctly. Right then. Get the chip in. I've got these here. We'll put one of these in. Might just clean them legs up actually, because this anti-static foam seems to be disintegrating. Clean that up. side up as well. You can see there's quite a lot of crud on there. Make sure this goes in the right way. So the polarizing mark, which is here, this side here, is going to line up with the polarizing mark on this side here. So all of these chips are polarized to the left. Sprung out slightly. Okay. What we'll do, get this device on the go here. Now this should drop straight in, which it does. Okay, that's fitted in nicely. Move them out of the way. Next plant, we will connect these in. It's the third pin back. Connecting the logic analyzer back up. Like so. I'm keen to see if there's any difference. So keyboard back again. Right then. Let's get the logic analyzer software back up and running. Logic. And back onto screen. Screen. Which one do I want to be on? Let's see. OBS. Why is that not loaded? I know why. There we go. Okay, we're back. So, have a look on here. I'm going to do exactly the same thing as what I did before. Ooh, now. That's really, really good. I don't know whether you can... Yeah, I'm back. I don't know whether you've seen the difference already. Straight away, I can see a massive difference there in the fact that as soon as I've replaced that chip, so channel 0 is... So this channel 0 is now the new chip that I've just replaced. And channel 1 is the original one that's been repaired previously. And basically now, we look at these waveforms, about 2 seconds in, so about this 2-second marker here, around about that time, we saw that the chip that had previously been replaced carried on with some kind of expected waveform, but the other chip didn't. Now that is really fantastic news. And that looks to me like a good data signal there. I'm really pleased about that. And I think we're definitely heading along the right lines. If we are, that would indicate to me that this particular board I had 7 faulty RAM chips because I did check out all of the data lines. In fact, actually, did I, didn't I? I'm sure I checked all the data lines out, but maybe I did, maybe I didn't. So I think what we'll do, if we swap one of these logic lines, we'll swap them down onto a chip that's still soldered on the board, and it'll be interesting to see whether the waveform compares to the one we've just replaced and how that compares to the originally fitted one. So I'm going to do that. Power that off. I'm going to move this one down here, and we'll go back onto the desk view and just see that. So we've got, this is the chip that was replaced as we bought the computer. This is the chip that we've just socketed and replaced from our replacements. These are the ones that we still think are original. So what I'm going to do, I'm going to connect that up. Let's try and get this one here. 1, 2, 3. Connect that onto that. Get that onto there. And now we'll go back onto screen and A64. And right, so there you go. Brilliant. So this top waveform is the new chip that we've just fitted, and we can see here we've got pretty much what looks like some kind of refresh cycle or data progressing there. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. But on this other chip, which is this channel 1, which is this one down here, that is not a clean waveform at all, which would indicate to me that that is definitely a bad chip. We probably do need to check all of those chips, I think. So yeah, I think we'll do that. Not take us too long. So I've moved down to the next one and start, power on, and yeah, we've dropped the waveform straight away. Yeah. So power off. We'll go and test the next one. So 1, 2. So test that one there. Okay, and we're gonna get ready again. Again, this one's dropped off. And go on to the next one. And we're going to get ready again. And again, we see that we lose the signal. This one. Bank. And go. Ah, now, interestingly, that's interesting. It looks like that last chip is working. Yeah, it does. That is interesting. I don't know whether you can see that. Normally after 2 seconds, so 2 seconds up here, normally around about the 2 second mark, it's normally dropped off. This to me looks like a valid waveform. Now there was one chip left to test, which was this one here. Ah, that's strange. That's strange, because that chip wasn't working a minute ago. so both of those have shown this odd wave signal. I think what I'll do, back to the comments. Sorry, I've just seen. Ouch, you have a lot of work ahead of you. Yeah, I do believe that that's the case. And how do all the chips fail at once? Yeah, I mean, age is definitely against them, and there was a known problem with the construction methods of a lot of these types of RAM chips. Now, it could have also been a power supply issue. The power supply for these, they were like a little brick, a tiny rectangular power block with a mains lead on one side and the voltage out. What they were known for is, as they aged, their output level started to rise, I believe, or it wasn't stable enough. Now, it may well be that an external power influence has caused it. Plus, also, we don't know, if somebody's connected a different power supply to it, or what's actually happened to it in the past. You buy anything from eBay, you've got no idea really what its background is. But I think for me, the confidence is replacing that chip. I'm going to put both of those Logic Pros back on those first two chips, which are the socketed chips, just to convince myself that what I've seen on the screen is definitely correct. And then occasionally these sockets actually hook themselves on really well. There we go. Right, so I'm going to stick the yellow one on this first one. And we're going to stick the green one on the second one. Like so. Okay. Run again. Yeah. I think when this happens here, this is just a refresh, and going back to the failing point, I think is going to be about this 2-second mark. So yeah, somewhere up around about 2 seconds. We should see this waveform change as well, actually. Let's have a look. I think what's actually happening is, as the processor boots up, it's obviously going to go through its boot sequence, and it's going to start reading data from the OS ROM, and it's then going to load data to start its boot up sequence into these RAM chips. I think what's happening is these RAM chips are then obviously corrupting the data. You end up in a situation where the processor then becomes in an unknown state, trying to execute who knows what. And then obviously, where we can see these cycles here, I think this is a refresh cycle, but the processor itself isn't operating effectively anymore. On the fact that I'm going to swap one of these lines out again, so we're going to keep the new one. Let's go for another random one. 1, 2, 3. Onto there. Just going to do another run. Yeah. And I mean, you can see here, this is fairly close, but not quite. Not quite at all. I'm happy that we're definitely heading in the right direction. I'm going to swap out all of these RAM chips. I'm going to get them socketed. And I'm going to come back. I'm probably going to end this stream now. I think we've made enough progress to satisfy ourselves that that's what it is. We've been on for... How long have we been on for? Should tell me here somewhere, I'm sure. Yeah, an hour and a half. Got quite some time ahead. I do want to save these chips, so I'm going to go at it carefully. I'm going to desolder them. I'm going to end the stream, and I'm going to come back when I've replaced all of the RAM chips. So please give us a subscribe, turn your notification bell on, and you'll get notified when I'm back live, and we'll test this board out and see how we get on. Thank you very much, everybody who's been here. Thank you very much, everybody. And I'm going to end the stream now. Thanks very much.